Good evening, my dear students. So tonight, we will discuss the final module on Capstone Project, which will be about work-energy relationship. So sa module na to, titingnan natin kung kailan binabago ng isang force na gumagawa ng work sa isang bagay, yung energy or yung total mechanical energy to be exact ng bagay na yon. Okay? So that would be work-energy relationship. So I would like you that before we categorize forces into two ways or into two groups, di ba? We have contact forces, so yung mga nakita na dyan. So para mabuo yung forces na to, kailangan may physical contact yung dalawang bagay. And then there are forces as well that happens or that occurs even though the objects interacting are a distance away, di ba? Like for example, gravitational force and electric force. But in this module, we will use another categorization of force. So dito, alamin natin kung saan nakabilang yung mga forces na ito na nasa kanan, alin sa kanila ang external at alin sa kanila ang internal forces. Okay? Because that would be important for us para maunawaan natin kung kailan magbabago yung mechanical energy ng isang bagay. So ito yung listahan natin. External forces would be or would include applied force, frictional force, tension, normal force, air resistance. Meanwhile, internal forces will include gravitational force, spring force, electric force, and magnetic force. So most of the time, we will only be dealing with gravitational and spring force in this module, as well as some of the applied force, external forces rather. So ano yung definition natin ng external saka internal force? So kung yung force na yon, for example, applied force, ay gumagawa ng work sa isang bagay, external force siya kung kaya niyang baguhin yung total mechanical energy ng isang bagay. Ibig sabihin nun, yung total mechanical energy nung simula, pag na-apply na yung force, will not be equal to the final mechanical energy. Pero kapag internal force, yung gumagawa ng work on an object, i-change na lang in one form or another yung total mechanical energy. Pero hindi nagbabago yung sum noon. Diba? Ang total mechanical energy, that means kinetic and potential energy. Although, nagbabago, halimbawa, from potential energy to kinetic energy, yung form ng energy na meron yung object. Kapag pinag-add mo yung dalawa, KE and PE, hindi makikita mo na at all times, hindi nagbabago yung total mechanical energy ng isang object. So, TME, initial, is equal to the final. Remember, TME is kinetic energy plus potential energy. So, I think you can still remember this one, diba? So, according to our grouping, gravitational force is an example of an internal force. Kasi, kino-conserve niya yung mechanical energy ng, in this example, a skier. So, kita natin that at all points, yung total mechanical energy na meron siya ay equals sa 50,000 joules or 50 kilojoules. May kita din natin na at different points, may changes or may transformation dun sa form of energy na meron yung skier. For example, at this initial position, kung saan nakatigil pa siya, so walang speed, diba? That would result to a 0 KE. Pero maximum yung kanyang PE, 50 joules or 50 kilojoules. And then halfway, this incline, lumait na yung niya, diba? Yung potential energy niya kasi mas malapit na siya sa ground. But as he is going down, bumibilis siya. So some of the potential energy is transformed to kinetic energy. But if you have them, that's still 50 kilojoules. When he reached the ground, so narating niya yung zero height position, that will result to a zero potential energy. Pero he is fastest sa part na yun, dun sa portion na yun ng kanyang travel or ng kanyang motion, trajectory. That's why virtually all of the potential energy was transformed into kinetic energy. So siya na yung equal sa 50 kilojoules. See the difference. Okay? So since gravitational potential energy is an internal force, although it's doing work on the skier, it is not changing the total mechanical energy, but only transforming it in one form to another. Okay, so sabi natin, may yung mga external forces tulad ng applied force, kaya niyang baguhin, di ba? Yung TME ng isang bagay kapag nag-apply siya ng work or if it did work on that object. So, sinabi natin nagbabago, that means it can either increase the TME, di ba? Or decrease it. Kailan siya nag-add ng mechanical energy? Kapag positive yung work ng ginagawa ng external force. That means, yung force and the resulting displacement ay on the same direction. Di ba remember, FD cosine theta? Actually, ito yung magsasabi sa'yo kung positive or negative, di ba? Pag cosine 0, positive. Pag cosine 180, negative. Kasi, yung direction ng force is totally opposite. That's the direction of the displacement. Okay? Ang mangyayari doon, it will lose mechanical energy. So, yung final would be less than the initial kapag negative work. While if pag positive work, the initial will be greater than the final. So, finally, let's meet the equation that we will use in this module. So, TME, initial, plus work done by external force is equal to the TME, final. So, bakit po yung work done by external force lang yung i-consider natin? Remember na kapag kapag internal force ang gumawa ng work, it doesn't really change the diba, the total mechanical energy. That means magiging zero to kapag internal force yung present sa atin. Also remember na TME, that means kinetic energy, potential energy. So the initial of both of them. And then here on the right side, the final kinetic and potential energies. Remember as well na pwede itong maging positive, di ba? Kung positive yung work, and negative if negative yung work. So that means kapag negative siya, negative work, babawasan niya yung di ba? Babawasan niya yung initial TME that will result to pagbaba noong final total mechanical energy. And then potential energy can be spring and gravitational. But most of the problems will only deal with gravitational. Later on, palalabas itong spring dun sa bar graph illustrations. Sige. Working with work energy equation kasi hindi naman palaging present yung kinetic, diba? Hindi naman laging present yung potential energy. What I mean is, most of the time, maaring mag-zero yung isa man sa dalawa, diba? So, pwedeng ito or yung kinetic energy. Depende sa case. So, that means you will really be finding yourself simplifying the equation. Let's consider this first case. Consider a weightlifter who applies an upwards force. So, yan, nagbubuhat siya ng barbell, di ba? Nag-apply siya ng applied force para mag-displace siya ng 0.25 meters at a constant speed. So, the first thing that you will do is, syempre, you write the mother equation. You break it down into this, the total mechanical energy, you break it down into KE and PE. Do it also in the right side. So, hindi tayo mag-solve dito, no? Gusto lang natin pakita kung paano i-simplify yung equation. So, bakit nawala yung KE? KEI, KEF. Gumagalaw naman, sir, yung barbell, di ba? Yun yung object na interesado tayo, di ba, in this problem. The barbell is moving. Why are we not putting any values on KE? Kasi sabi, constant yung speed, di ba? Remember, square. Here. If hindi nagbago yung speed mo, that will result to 0 here. So, this is 0, and this is 0. Because, kung parehas yung, okay, let me repeat that. Kung parehas yung velocity, if this is the initial and then this is the final, for example, if you put it right there, if you transpose, magiging negative siya, diba? So, assume no, the variable will not change its mass, diba? But if this is the same, for example, 2 meter per second, 2 meter per second, So I hope you can see na magiging equal lang sa 0 yung subtraction nila, di ba? So that's why we will not be considering the KE, the kinetic energy, because there's no change. So you raise the barbell higher from the ground. So ni-raise mo siya, you will expect na nag-increase yung iyong, or may pagbabago sa iyong potential energy. That's why expect na mariretain mo yung iyong potential energy in your equation. And then the external force doing the work is applied force, and of course meron kang displacement, and the cosine is 0. So it's doing positive work, force, and then the displace niya pataas din, di ba? So yan yung ano mo, yung equation na paglalagyan mo ng mga values. Okay, let's have another one. Now consider a baseball catcher who applies a rightward force to a leftward moving baseball to bring it from a high speed to a rest position over a given distance. So there are many things that you have to notice here. High speed to a rest position. Oh, there's a change in speed. That means nagbago yung iyong kinetic energy, di ba? So expect na dapat ma-retain mo yung K, E, I, and F. And then who applies a rightward force? The force is rightward, but the displacement is leftward. That should give you a clue that the work is negative. Do we have a PE as well? Okay. Yes, we do. The baseball is higher, di ba? Is high above the ground. So expect that you will also have a value for PE, I, or PEF. Except if we assume na hindi nagbago nung tinos siya ng batter, ng pitcher. Diba? This is the batter in this position. If hindi nagbago yung height niya, kung tuwid-tuwid siya, if the height is the same all over, okay, so don't expect that there will be no change in the potential energy. Diba? That's the time that we can assume that it's 0. Or not 0 actually. Assume that we can cancel it out. Okay, this one. Now consider a car that is skidding. Ibig sabihin nagpapreno siya from a high speed to a lower speed. Okay, that's a clue. There's a change in kinetic energy. The force of friction between the tires, frictional force, that's external force, and the road exerts a leftward force on the rightward moving car over a given distance, say 30 meters. Oh, by the way, I forgot something. So, dapat negative yung external force mo dito, di ba? Kasi negative work yung nangyayari. So, negative work done by the external force. And then, going back here, so wala kang PE dito kasi nasa ground, nasa road yung car mo, di ba? So, it is at a 0 height position. KEI plus PEI, negative na natin yung work done by the external force. KEF plus PEF. Let's cancel it out. Okay. Kung gusto mo, gawin na natin to. Cosine theta equals KEF. Also, okay. Wala palang sinabing tumigil siya from a high to a lower speed. Pero kapag tumigil siya, di ba, what will happen to the velocity? The speed will be 0. So that expect that using this formula, maging 0 din yung final mo, di ba?